Saxon's Trig, lesson 68 on page 430 is about locus definition of a parabola, translated parabolas, then some application problems, and finally a derivation of how we get to a part of this formula that we're going to find here in section A. So let's just start with section A, locus definition of a parabola. So we know that a parabola is any of our U curves, and our formula has a plane X or Y, and then the other one, X or Y, is squared. Now, locus means this identical distance from something. So if you look over on the top of 431, it has a box, which we know to be of extreme importance, and it is the locus definition of a parabola. A parabola is the locus of all points that are equidistant from a given point, and that's called the focus. Okay, so try to take the wordiness out of that. There is a point always found in the opening of the parabola, and that is the focus point. And it's saying that no matter which direction I go, I am getting the same distance with those mirror image points. I didn't graph that one very well, but it's the same distance no matter where I'm going, because the focus point is actually on the mirror, this axis of symmetry piece. Okay, so a parabola is the locus of all the points that are equidistant from a given point called the focus and a given line. Okay, so now if the distance between the focus point and the vertex is 2, running to the other direction is a line, and that is called the directrix line, and that's what it's telling you here, and a given line called the directrix. So when I drew these lines, I was drawing them to the parabola itself. However, the technical definition is saying that I am directing this to the same mirror image spot on that line. Okay, so that is the locus definition of a parabola. Then the new piece for you is that in the equation, you will have, and you'll need to memorize this, 1 over 4p in front of your x squared. And also, and that's when your focus point is 0p. So that's where that p is coming from. And you also need that y equals negative p is your directrix line. Okay, now that you have those, there's another box of extreme importance near the bottom of page 431, the graph of the quadratic function y equals ax squared is a parabola whose vertex is at 0, 0, because there's no extra numbers added in there, whose focus is 0p, as I set up there, and whose directrix is, as I said, y equals negative p, where the a is the 1 over 4p. So it's the wordiness of telling you the specifics of this equation, which I basically was giving you here. All right, so the next box says the parabola with the vertex 0, 0, and a focus of 0p and a directrix of y equals negative p will be the equation y equals 1 over 4p multiplying with the x squared. So it's the things I just gave you, they're just writing them out in the actual formulas. Okay, example 1 begins on page 432. Based on this information, find the coordinates of the focus and the equation of the directrix for y equals 3/7 x squared. Okay, so it wants the focus point, and the focus point is 0p. So I need to figure out what this is based on the fact that this 3/7 is falling into this 1 over, where the a is 1 over 4p, either place you're pulling it. So the a equals 1 over 4p, and we are saying that the A is the 3/7 matching with the 1 over 4p. So how can I solve for the p? Well, this is, I can treat it as a proportion and cross multiply it. So if I do that, then 7 times 1 is 7, and that equals 3 times 4, which is 12p. And then we divide, p is 7/12. So I have, if it wants the focus point, we know that that is then 0p, p is 7/12, so here is my focus point. And it wants the directrix, which is y equals negative p, negative 7/12. Double checking. That's all they need because that's all they asked for. Now they did graph in the example to show you what that looks like. So even though it's not part of what they're asking you to do, just so you get the idea, if the focus point, which was 0 and 7/12, so that's before you get to the 1. If you picture that divided into 12 parts, you only want 7 of them, wherever that's going to be. That's my focus point, which I know is somewhere in the opening. And my directrix is at negative 7/12, so that's somewhere just above the -1. And the directrix line is often given in a dashed, and I know I did it solid here, but it's often dashed. So the vertex point would be halfway between those two, and wherever that halfway mark would be, I'm going to guess that it's just a little below 0. Oh, no, they're saying it's right on 0. I knew it had to be close. All right, and then because the parabola opens around the focus point, I know that it's going to be opening something like this. Now, I don't know how wide it is unless I plug in some numbers, but that gives you the idea of how the focus point and the directrix line can then help you find the vertex point, which then can help you do the graph. Example 2. The focus of a parabola has coordinates of 0, -5/3. And a vertex is at the origin, so vertex is at 0, 0. Find the equation of the parabola and sketch it. So this one does want the sketch. So the first part is to find the equation, which is your y equals something or other x squared. And I know I don't need to worry about any numbers attaching with the y or with the x because the vertex is 0, 0. But I am going to have to deal with the fact that 1 over 4p has to equal the -5/3 from the focus point. Cross multiply again, so -20p equals 3. P is -3 over 20. And then I can fill that in here, -3 over 20x squared. So there is the equation of the line that it asks for. And now sketch it. Okay, so vertex point was at 0, 0. Focus point was at 0, -5.3. So 5/3, that's -1 and 2/3. So that's going to be, need some dashes in here. Okay, so just almost getting to -2, but not quite, is my focus point. So I now know that the parabola is definitely opening downward where the focus point is, and my directrix line is the opposite direction. We didn't write that out, but it's the opposite direction from this of 1 and 2/3. So it's about here with its dashed line. If I want to go ahead and put it there, so that would be y equals +5/3. To get the actual spacing, I need to plug in a number so I can get a mirror image. And I can't use 0 because it's my vertex point. So let's plug in 1 and see what happens. 1 squared is 1. 1 times -3/20 is -3/20. All right, so that would be estimating this split into 20 parts, and I only need 3 of them. So that's uber tight to the 0. So that's really wide. And then I know that I would mirror image that point over here with the -1. So I now get a very wide parabola graphed. Part B is translated parabolas. So in those examples, my vertex point was at 0, 0. This is what is happening when it's not. And I have some key boxes here. Equation of a translated parabola. The equation of a parabola whose graph is the graph, and so the normal one is y equals ax squared. Translated h units horizontally. So horizontally is this way. On my x-axis, we're moving it h. And k units vertically. So vertically is this way. So we're doing k up or down. The formula changes to y, and because we're changing it by a k, minus k, because we're attached to the y, equals the a, and then, oh, I'm sorry, I'm running into my hole here, x minus the h, and the formula has that squared. Okay. The next box says a parabola whose vertex is hk. Now that's the same information here. So the vertex is hk, and the focus is h with k plus p. Has the equation of, and this is very important to memorize, this k plus p, because you begin to use it in the next, the set of problems that they're going to have you do in the homework and the next examples. So, but here is the formula as they give it to you. Y, as you would expect, minus k from here equals, and then you have your 1 over 4p, because it's going back to that formula from before, with our x minus the value that we've moved it, h, and it's squared. So this, and it also clarifies in the box, the axis of symmetry is x equals h, because whatever the x value is, that's what your mirror line is going to be. So this is kind of the ultimate combination equation of everything that we've just talked about. At the bottom of that page, they show you positives and negatives in front of this, either opens you up or down, which we should already know. So example 3 says a parabola has a vertex of -2, 1 vertex, and a focus of -2, -1. That's my focus point. Write the equation for the parabola, the directrix, the axis of symmetry, and then sketch the parabola. So we know that our vertex point is labeled h, k from here. And our focus point is labeled hk plus p from here. The h's are the same, -2. They will always be the same. So if you have different numbers here, they've given you a problem that's not solvable. And then my k is 1, and I can find my p, which I know I need for the equation, by using this part. So 1 from the k plus the unknown p equals -1. So p has to be, minusing 1, -2. Now I know p, I can plug into my equation. So y, and we need the vertex point, not the focus point. Don't make that mistake. So in this equation, it's your vertex point that you need. So y minus k would be -1 equals 1 over 4 times the p, which is -2, multiplying with x minus the h. So minus the -2 makes it +2, and it's squared. And then do a little simplification work. I'll solve it in just a second. Let me fix this first. So this becomes 1 over -8, or -1/8, doesn't really matter, x plus 2 squared. And then for graphing purposes, I actually need to move this 1 back over here so that it reads y equals, so that's going to make it +1 at the end. So now we're in the right format. This is what I could box for the equation for the parabola. The directrix we know is y equals -p, so y equals +2, because that's the opposite of -2. The axis of symmetry, so that is your h value, so x equals -2 is your axis of symmetry. Make sure I haven't skipped anything. Equation of the parabola, directrix, axis of symmetry, sketch it. So these will be the equations I will box and then the sketch. Vertex point, -2, +1, starting place. Now I don't have to put the focus point in there, but I'm going to because I have it. So that's -2, -1, focus point. And I like to label that one with the F so I don't get it confused with my vertex point. I don't tend to label that one with the V because I know my graph is happening up here and it tends to go over the letter, and I try to avoid that if I can. Then I can do the directrix line. So the directrix line was x equals negative, wait a minute. Yes? Just a second, did I put my no? X, oh good grief, that's axis of symmetry. That's my mirror, sorry. Y equals 2, there we go, that's making a whole lot more sense to me. My dashed line for the directrix is here at -2, which should be the opposite direction from the focus point. That should be the same distance. I still feel like I have a problem because that's 2 units. This should be 2 units above. Good grief, hang on, did I write this incorrectly? This should be at 3 for sure. Oh, that spacing is bad, but it should, if this is 2 below, this should be 2 above at 3. It should be y equals 3. Okay, hang on. Where did I go wrong here? Because I pulled it from here. No, that's this one. Okay, it just hit me where I was mentally derailing. My instinct said, and that's how I started it, y equals -p, which is why I wrote it as a 2. What I failed to take into account was that I am not starting at 0. I am starting at, on the y-axis, at 1. So I needed to do 1 plus the extra 2, making the 3. I instinctively do it when I graph it, but be careful then when you're doing the numbers you don't make the error I did, and you won't because you're not instinctively memorizing the y equals -p. But you need to do for the directrix point the opposite of your P, adding with your original vertex number. Okay, now that I've clarified that, back to my graph, I'm going to plug in 0 to see how wide this should be. So 0 plus 2 is 2, squared to 4. 4 times -8 underneath, so that's going to be -1/2 plus 1, which is a common denominator of 2 over 2, so that would be 1/2. So 0 graphs a 1/2. That's 2 away from the vertex point. So to the other direction at the same 1/2. Fairly wide parabola again. Now I've graphed it. Okay, moving on to section C, the application kind of questions. So at the bottom of page 434, I see that if I take a parabola and I rotate it 360 degrees, I'm forming things like the curvature of a contact lens, a satellite dish. These are applications for how parabolas are helpful in the real world, and especially when we rotate them 360 degrees. So they're using a satellite dish, or they're talking about light hitting this dish and then bouncing back off. And so the where the curvature is, or where the focus point is, becomes really important for where light should bounce. And so if you know where the light is supposed to bounce on a dish, then you can adjust by adjusting the focus point. Okay, so having said that, here's example 4. The reflecting surface of a parabolic antenna has the shape formed when the parabola for this equation, y equals 1/20 x squared, is rotated about the axis of symmetry. If the measurements are in feet, how far from the vertex should the receiver be placed, the focus point, if it is to be at the focus. Okay, so do I need the graph? How far should the focus point? Not the curved graph per se. No, I don't even think I really need to graph it, because I do know that my 1/20th is equaling the 1 over 4p, and the p has to do with the focus point. So if we solve here for the p, 20 equals 4p, p is 5, and there were no other numbers attached with this. So that tells me that the vertex point is at 0, 0. And because of that, there's no adjusting to my, because this is going to be 0 plus p for the focus point. So that focus point is going to be at 0, 5. And so that's telling me that it's 5 feet, because it said dimensions were in feet, 5 feet from the vertex would be a good wording to use there. Now, if you graph it, you would be able to say even more specifically, like to the positive, if I'm looking at their picture. Without the picture, I'm kind of guessing as to which way it would go, but I do know that it's opening upward, it's positive, so that does give me another clue. But you don't have to get that super specific. If you're getting me to the 5 feet, we're good. I'm going to stop the video here and do the deriving of the formula in another one.